Now, above we made a note. So as we've already made note, if two lines are parallel, they will have no solution, which is not always true, but almost always true, because they're never going to cross. They're parallel. It's like train tracks. And train tracks, the tracks will always be parallel. They'll never end up crossing. But systems that have different slopes will have one and only one solution. If a system of equations is coincident, so if they are identical, then they will have an infinite number of solutions because they're always crossing each other. So that would be one line on top of another line, and they're the exact same line, so they're always intersecting because they are the same line. So looking at the following graphs, determine the number of solutions. So this right here looks parallel, and you could confirm that if you wanted to. So we can go, where is it? So down 1, 3 to the right. Down 1, 3 to the right. And is that going to be the same thing on this one? So this looks like a nice spot here. Down 1, 3 to the right. Yeah. So they have the same slope. So these are parallel. So the number of solutions by looking. So I would write that this is parallel. Therefore, there are no solutions. There's no way these things will cross. Now for B here, obviously they cross once. And that's because they have different slopes. So they have different slopes. And different slopes will mean that there's one solution. So we have no solutions on the left, one solution on the middle. Now on the right, you can see that it looks like it's one giant line, and that's because I've just bolded it. That simply means that the lines are on top of each other. They're the exact same line. So they are parallel, yes. But actually, they are identical. So if they're identical, therefore we can say infinite solutions. And the way we write infinity is like that. So infinite solutions. So parallel lines mean that there's no solutions except when the parallel lines are actually on top of each other, in which case they're the same line, which means that there's an infinite number of solutions. So there is our 3 answers. And now we can look at the second question here. I'll just zoom out. Okay, there we go. So now what we're going to do is we're going to use the slope-intercept form of the equation, and we're going to compare it. So we're going to, here we could look at the slopes and look at the drawings, but now we're actually going to look at the equation. So we want to state the number of solutions just by looking. So I can see here that this is parallel. But it's not identical. Okay, we can, I mean, it's obvious. That says +5, that says -5. Not identical. So if it's parallel but not identical, then you can say, therefore, what do you know about parallel lines? Well, parallel lines never cross, so there's no solutions. So we took a look at the slopes, and we found that they were parallel, but the whole thing was not identical, so we could say there's no solutions. Here, take a look at the slopes, and I say, oh, hey, they're parallel again. But then I look at the equations, and I'm like, oh, they're identical. So if they're identical, we can say, well, if things are identical, then that means one line's right on top of the other. we can say, therefore, there is an infinite number of solutions. Okay, let's take a look here at C. Now take a look at the slope. One of them is -1/2, the other one is a +2. These are different slopes. And whenever we have different slopes, like one slope is like this, the other one's like this, well, eventually they're going to cross. One slope is here, the other slope is here, eventually they'll cross, and they'll only ever cross once. So different slopes mean, therefore, there's always going to be one solution. Now, it turns out that these slopes actually are perpendicular. I don't know if you can remember that. This is 1/2, the other is 2/1. So they're flipped fractions, but also one's negative, one's positive. That was perpendicular. That's of no importance, but it's just good to remember. Here we have 3/2 and 2/3, not perpendicular. Yes, they're flipped fractions from each other, but they're both positive. One needs to be negative. But anyways, regardless, they're different slopes. So different slopes. Therefore, when you have different slopes, we have one solution. So this is pretty straightforward, except that we're now going to do 4 questions where they're not in the same form. They're not with y equals. So we have to do 2 things of algebra, and then we're going to compare them. So let's take a look here. So both of these. I do not know at all what these are. I can't tell if they're parallel, I mean, I can tell if they're the same. So do these look the same? No, they're close, but one's a -12, one's a +12. This is not the same. This is not, like, none of them look the same. Okay, well, there we go. So what we need to do, I guess, is maybe just split this up and write the equations on both sides. 2x plus 5y minus 10 equals 0. And you want to get the y alone. So we're going to get the y alone. We're going to minus the 2x. Well, I usually like to get rid of the number first. So I'll add 10, and I'll add 10. So 2x plus 5y equals 0 plus 10 is 10. And now I can minus the 2x from both sides. Now, I can't go to 10 minus 2 is 8. I can't do that because they're not alike. These are not like terms. So we've got 5y equals, like I said before, I like to write the x first, excuse me. So I'll write that negative 2x first, and then the 10. And then lastly here, I can divide by the 5. So y equals negative 2/5 x 10/5 is 2. Great. So we've got lots of room here. Now I need to do the other one here and take a look to see if the slopes will be the same or if they'll be different. So I'll write the bottom one. 2x minus 5y plus 10 is equal to 0. So I'll minus the 10 over to this side. I have 2x minus 5y is equal to negative 10. And then I can minus this 2x over to here. Again, I cannot combine them because they are not alike. So I just have the negative 5y. I'll move it over a little bit here. Negative 5y equals, I'll do the x first, so the minus 2x and then the minus 10. And then I can divide by negative 5, divide by negative 5, and divide by negative 5. So y equals, now negative 2 over negative 5 is a positive 2 over positive 5. The negatives, there's two of them, so they cancel. Same over here, negative 10 and negative 5 divided is going to be a positive 2. So comparing these, so I've got a negative 2 over 5 and a positive 2 over 5. Sorry. So that's my slope, and that's my slope. They are different slopes. They're not identical. So different slopes. All of that work. Different slopes. Therefore, if you have things that are different slope, so one slope is like that, one steepness is like that, the other steepness is a little bit different, they're always going to cross once. Therefore, one solution. Okay, so I'll just try to zoom out here for you to take a look. At these. Alright, let's take a look at the next one here, letter F. Also notice that it does not have y equals, so we can't just look at it and tell right away what the slopes are. So let's take a look. Let's write 3x minus 4y. So 3x minus 4y. How much space do I have? I think I have a little bit more. So 3x minus 4y minus 12 equals 0. And we need to get the y alone, so let's add the 12 over to the other side. So 3x minus 4y, not 14, is equal to 12. And then we can minus the 3x over to the other side. Now I can't combine the 12 and the 3 because they are not alike. They are not like terms. So I'm just going to have to keep them separate. So I have the negative 4y. I'll write the x first, negative 3x, and then I'll have the positive 12. And then I can divide by negative 4 on everything. So y equals, now these negatives will cancel out, so it's a positive 3 over 4x. 12 divided by negative 4 is a negative 3. Okay. Let's try the other one. Now the other one is 3x minus 4y plus 12 is equal to 0. So that's the bottom equation. So almost identical, but first we'll minus this 12 over. Okay. So 3x minus 4y is equal to negative 12. Then I can minus the 3x. And like I've said a million times already, you cannot combine the x with the 12, the 3 and the 12, because they are not alike. So I've just got a negative 4y is equal to negative 3x minus 12. And then we'll divide by negative 4. Everything. And what do we have? Y equals negative over negative is positive. So positive 3 over 4. And negative 12 divided by negative 4 is a positive 3. Okay, so let's take a look at the slopes. So it's on the left here, 3 over 4, and over here, 3 over 4. So the slopes are identical. The equations are not the same. So they are parallel, which is awesome. Figured that out. but they're not identical. So it's good to keep that in mind. They're not the same. So if things are parallel, and they're not the same equation, if they're parallel, they're like train tracks, they will never cross. Therefore, how many times will they cross? Never. No solutions. Therefore, no solutions. Okay, so I'll just zoom out here in case you need to copy anything down. And lastly, G. Now, G is kind of nice, only because when we split this down, the bottom equation, y equals 3 over 4x minus 3, doesn't need to be adjusted. It's already y equals, which is awesome. So we have 3x minus 4y minus 12 is equal to 0. So let's get this one, the y alone. So let's add the 12 over. So I've got a 3x minus 4y, 0 plus 12 is 12. I'll minus this 3x over, and again, I can't combine them because they're not alike. So I just have the negative 4y equals the negative 3x and then the positive 12. Did I already do this question? No. Oh yeah, I could have just copied it. It's right there. So 3x minus, yeah. So I could have just written the solution down, but I'm almost done here. So divide by negative 4, and negative 4. And negative 4 from negative 4 will cancel. So y equals, y equals negative 3 over negative 4 is a positive 3 over 4. Two negatives cancel out with the x there, and 12 divided by negative 4 is negative 3. So take a look at the slopes here. So the slope is 3 over 4. And well, I look at these here, and they're actually identical. 3 over 4x, 3 over 4x, minus 3, yeah. So yes, they're parallel. That is good to note. But the more important thing here is that they are identical. That's really good to note, because if they're identical, they're always going to be on top. They're going to be crossing each other at all times. They're always going to be intersecting. So we can say, therefore, there is an infinite number of solutions. Okay, so I'll just zoom out there. There's a ton of work. This video is way longer than what I wanted it to be, but we did a lot here. E, F, and G. There's a ton of work that goes into this. I could have made it easier on myself and not even done all of this work because I actually already did it over here. But whatever. I guess that's done.